Hi everyone, we're going to find the critical numbers for f, find the open interval where f is increasing or decreasing, and also apply the first derivative test to identify all relative extremum. So when I take the derivative of this, I'm going to get 2/3 x minus 1/3, and this is going to equal 2/3x to the 1/3. Basically, we have a discontinuity at x equals 0. And so that's the number I'm going to use use my test intervals for this one right here. So again, my derivative, my test numbers, so we're going to treat it like a critical number, would be x equals 0. So my test intervals are going to be from -infinity to 0, and then from 0 to infinity, and we're plugging it in our derivative, and our derivative is 2/x, 3x to the 1/3. So I'm going to plug in -1, and if I plug in -1, the denominator is going to be negative. So I'm going to have a positive over negative, so this is going to be negative. So our sign is negative. When I plug in a positive 1, both my numerator and denominator are going to be positive. So we have a positive. The conclusion is, since this is negative, that this is decreasing on the interval -infinity to 0 and increasing on the interval 0 to infinity. So basically, when you look at this, we have a decreasing interval, which means going down, then we're going back up. So we're going to have a relative minimum, and I'm going to take my original equation, which was f of x equals x to the 2/3 minus 4, and I'm going to plug in my critical number, or my point of discontinuity, and I'm going to plug it in. So I have f of 0 equals 0 to the 2/3, which is just 0 minus 4. So at 0, -4, we have a relative minimum, since it's decreasing first, then increasing. So that's a relative minimum. And that's all. Thank you. Have a nice day. Bye-bye.